For a spring system, we have all kinds of arrangement. Sometimes one kind of arrangement is better than the other. Sometimes one type of arrangement can cause some kind of inconvenience to our life. But one thing we need to know is that the basic is still there. So let's say here is 2 kg and the extension is perhaps 0.5 meter or maybe 12 kg. Okay, make it 12 kg, and all of this will be using the 12 kg later as well. Okay, first of all, we need to understand a few points. This type of spring, this type of spring, this type of spring, this type of spring, and this type of spring, this type of spring are all similar, same type. So their K will be the same. The spring constant will be the same for all types of arrangement. But the total spring constant for each is different. So my first job is to find out this one first. F equals to Kx, mg equals to Kx. So we have 120 equals to K 0.5. I'm interested to find out the spring constant. 120 over 0.5. This one will give me 240. 240 Newton per meter. So let's call this A system, where it is series, while this one we can call it B system, it is in parallel. So what if 12 kg is the same? 12 kg is the same. Later we find out that even if the mass or weight is different, it's not going to change the fact that the new K for A is actually half of the OK. It's actually getting softer. The situation is the stiffness is getting softer. But as for this one is getting stiffer times 3, because there are 3 springs like this. K new for B. Okay, so here you should have a value of 720 Newton per meter. This one is half. If here there are 4, it will be 1 over 4. If it's 7, it's 1 over 7. So half of the original stiffness is 120 Newton per meter. Okay, this is proven by observation and also by mathematics. So next time you must memorize this. Series, it will be softer, so it will be divided by how many springs you are actually putting. As for this, it is parallel, so it has to be multiplied by how many springs you are putting in parallel. So you realize if you use logic or common sense, we understand that if 3 persons is supporting a weight, the extension is very little. The extension is very little. If extension little means the spring is actually stiff. This one, if this one is Mr. Derek and you are saving Mr. Donkey, so the donkey is saving a chicken. So Derek and Donkey is saving the chicken. So it seems like it will stretch a lot. It will stretch a lot. Okay, but of course this argument is not really professional because it's silly. Nevertheless, you just memorize that this one is getting softer, this one is getting stiffer. So the example calculation will be, if you use, if you look at situation A, we have a new K will be 120 Newton per meter. So I'm interested to find out what is the extension. So with the same mass, 12 kg, so 120 Newton, and this K is 120, new one. So the new extension is actually 1 meter. Then 1 meter compared to originally 0.5 meter. It has increased. Okay, 1 meter. So how about situation B? Situation B, the new one for B, this one new one for A, is equals to 720 Newton per meter. So F equals to Kx. So you have 120 equals to 720, and the new extension, this one. So the new extension is 120 over 720, so it's almost like 1 over 6, because 12 divided by 72 is 1 over 6. Yes, 1 over 6. 1 over 6 is like 1 meter chopped into 6 pieces. So 1 meter into 6 pieces, 1 over 6 is a value of 0.167 meter. So this is like 16.7 cm. So you comparatively, here is 16.7 cm. Look at the red line that I am putting forward. This one, and this one. You can see the comparison. This one is not getting bigger because it's cm. This one is 100 cm. This one is 50 cm. And now you can compare better, 16.7 cm. All compared in cm, you realize that the situation A is actually very long, and the situation B is actually very much shorter.